In this problem, you see we have two boats that leave the buyer P at the same time and travel in the directions as shown in this diagram. So if the boat A moves with a velocity that is 40 feet per second and the boat B moves with velocity that is 30 feet per second, so we have to find the velocity of boat A relative to the boat B. And how long after leaving the buyer will the boats be 1500 feet apart? So you see that the velocities of these two boards is not along x or y axis. So first of all, we have to find the perpendicular components of these two velocities. So for the velocity A, so you see that the velocity A is 40 sine 30 degrees along the x-axis and 40 cos 30 degrees with the y-axis. And the velocity B is 30 cos 45 degrees along x-axis and 30 sine 45 degrees with y-axis. As you see, in case of velocity A, we have sine component with x-axis and cos component with y-axis because of the angle, because you see that this 30-degree angle is with y-axis. And we know that the velocity of boat A is equal to velocity of boat B and plus the velocity of the boat A relative to boat B. So we have already uh, found the velocity of the boat A and velocity of boat B along its perpendicular component. So if we solve this, so we get the relative velocity that is negative 1.213 feet per second along the x-axis and 13.43 feet per second along the y-axis. So you see that this velocity is along its perpendicular component, so we have to take its magnitude. So we get 13.5 feet per second. So this is our relative velocity. And to find its direction angle, we can use tan inverse, that is a trigonometric value. So we get 84.8 degrees. So you see, we can find the time t that is required for boats A and B to be 1500 feet apart by noting that the boat B is at rest and boat A travels at a relative speed that is 13.48 feet per second. So we have T that is equal to distance that is 1500 divided by the relative velocity that is 13.48. So we get time that is 111.26 seconds or 1.85 minutes.